I got curious recently about how to create a custom shell. There are several shell options we have today. We have bash, very common and even the default in many Unix systems. We have ZSH, which is what I currently use. Recently I learned about fish and a couple others. And on Windows you have command prompt and PowerShell. And all of these shells, they fundamentally do the same thing, but they are different in a couple of ways. Some of them are more interactive than others, and some of them provide extra commands that other shells do not. But recently I was thinking, what if I wanted to build my own custom shell? And I realized it's actually not so difficult to build a custom shell. Don't get me wrong, it can be a very complex and complicated project depending on what you want to do with your shell, how interactive you want to make it, how fast you want to make it in processing user input, or what language you want to use in creating that shell. But the basic idea is very simple, and that's what I want to share with you in this video. And I also want to show you what I have built with this knowledge. Now, the first thing to understand, if you don't already, is the difference between a terminal and a shell. A terminal is basically an interface, a command line interface that allows you to write text, see text, copy text, paste text, do all of those text stuff. But if I should do something like cat or echo, the command line interface doesn't know what to do with this text. That's where a shell comes in. A shell is basically a command line interpreter. It takes the input in the command line, processes that input, interacts with your operating system, does a bunch of stuff, and sometimes it might produce an output and other times it might not produce an output. Now, this shell can be made with any language that allows you to receive inputs from the terminal. And you see several shells today created with maybe C or C++ or even Java or even Python or even Node.js. Anything that allows you to take inputs from a user on the terminal and that language can interact with the operating system and produce output. That's a shell. But we're going to be using Python in this video. So I have my Python script here, which can also be used as a shell. So the first thing we can do is to take an input from a user. Let's say user input is equals to, we have the input function which reads a string from standard input. And when we have this input, we can just say user input is, and we have the user input. Trust me, this is basically a shell, as simple as that sounds. Now, when I try to run this Python script, we get to this line where it asks me for input, and then my input is, my name is Dillian. And when I press enter, then we process the input where we print user input is, and then we have the input. This is basically a shell. But it doesn't make sense that if I want to enter another input again, I have to run the command, enter another input, and then press enter. I shouldn't have to run this command all the time. So this is where I can have a loop, something that constantly checks for the user input and tries to process that input. So instead of just having this like this, I'm going to put it in a while loop where I say, while true, keep doing this. Okay, so now if I should run this, okay, user input is something, we have this, it asks me again, user input, I don't know. Now we have this command line vibe where I can keep entering input and the input will be processed. Obviously, there's nothing done to the input here. It's just printing the input back to us. But one thing I want to call out before we go further is if I should do Ctrl+C, which is supposed to stop the current executing shell, what we have is this, an error. Because by doing Ctrl+C, we have the exception keyboard interrupt, which is thrown, but then we're not handling that exception. So when we try to run this while loop again, we now have an error. So this is where we can break from that while loop. So what we're going to do here is we're going to have a try and except where we try this, but if it throws an error and that error is a keyboard interrupt error, it says the program is interrupted by user. So when we have the keyboard interrupt exception, then we can print something like sad to see you go, and we can break from the while loop. Okay, let's try that again. Python 3. Okay, the user input, hi, something. But then when I throw that keyboard interrupt exception again by doing Ctrl+C, now we have sad to see you go. Another thing to call out, which you would see in many shells, is that, like you can also see, I'm currently using ZSH. By the way, if you want to know what shell you're using, I think that should be available on the shell variable bin/ZSH. But you can see on ZSH, we actually have this line here that shows us shell with some spaces, and shell is basically the directory I'm currently in. If I do pwd documents github shell, and if I go to github, if I just go back and I do wd again, we have this as the directory. So we can actually put something before the input that we are asking from users. So how you do that is in this input, you can enter a prompt. A prompt is basically what the user is going to see before they type that input. So in this prompt here, for example, we can put a $sign with a space, which I think is what bash does. So if we go into the bash shell, yeah, it shows the bash version 3.2, and it shows the $sign and a space, and then you can type something. We can actually do the same thing here. So we can put something like Deeecode and a $sign, and now we can enter our input. So if I should run this, see, we have Deeecode dollars, and I can do something, user input is something, and then we have Deeecode dollars again. But there's something ZSH does that I really like. As you can see, ZSH would show me the name of the current directory and then a space. And I also want that. I want to also get the current directory that I'm in a space, and then I can enter an input. Well, I can do that also in my shell. The first thing I will do here is to get the current working directory by calling os.getcwd. It's going to give me the whole working directory, but I just want the last part. Well, let me print this first. So you see absolute directory. See, it gives us this as the absolute directory, but this is the part that I need. So what I can do here is I can get the current directory to be absolute directory dot split, and I'm going to split by the slash. And when I split by the slash, I can get the last item in that array that we now have, which is going to be shell. And when I have that part here, I can now show it here. So I'm going to interpolate this variable current directory. I can just put maybe a nice arrow, or I can even put an emoji. Which emoji do I want to put? Let me put the rocket. Yeah, I can put the rocket here and then a space. Exit from this, and so now we have shell and this, and I can continue doing my thing. And if I should exit this and go back to the parent directory, because I cannot yet do that in my own shell, if I do this and now I run python 3 shell/main.py, you see we have GitHub as the current directory. Oh, and before we do something with the user's input, let's add some color. So here, when I run this, when I run this, it's just showing this boring color, but I actually want to put a particular color. So here I have a color used on terminals for yellow. I don't know how this means. You can get these colors online, but this is just basically going to give me a yellow color on the terminal. So here I can have my prompt as a separate variable for readability's sake, and then I'll have my color, and in the color, this is where I'm going to put the current directory. And now for this user input, I can pass prompt. So now if we run this, see, we have some color, which is not nice. I'm going to put an extra hyphen and a space here. So if we run this, see now, consistent, sorry. Now if you run this, see we have the hyphen, we have some space, and then we have the current directory, and there should be space before the rocket, but I missed that. But you get the point. You can add colors just the way ZSH is adding colors. So now when we get the user input, I want to split the user input by getting the command and the arguments. So the first thing I'm going to do is to strip the user input, so that if there are extra space, I can remove those spaces. So I can call user input.strip. I think in JavaScript, this is trim. It will remove the space from the beginning and from the end. And when I get this, I can get the command. So the command, which is the first word, is going to be user input strip 0. Well, actually, I should first check if the user even entered any inputs, because if they didn't enter any inputs, then it's just going to throw an error. Sorry, I keep putting semicolons. I'm just used to this from JavaScript. But here I can check if the length of the user input strip is 0, continue the loop. loop. Don't do anything with that information. But if they actually enter the command, I get that particular command here, and I can get the argument by saying user input stripped, and I think that is 1 colon, and it will get everything after the command. So here, if I should do command, and I do the same thing for args. Now, if I should run my script, and let's say we enter a command like hello, something, hi, whatever. Now, when I run this, the command is H. Oh, sorry, I was supposed to split this. So let's just say user input, something like this. And then, so here I'm going to split by space. Now it's possible the user can enter multiple spaces. In that case, you can use regex. I'm just going to assume the user would enter 1 space between the words. And from this user input, I can pass that here. I can pass that here and pass that here. Okay, let's try again. Now, if I should run this and I do hello, something, hi, whatever, I'm getting this error because this is a list and it is not a normal string. I'm just going to join the args here so that it's a string. Okay, let's go again. Hello, something, whatever, hi. Good. So for the command, we have hello, which is the first word. And for the args, we have every other thing that comes after hello. I want to execute this command. Now, the interesting thing I can do here is instead of processing this command myself, I can actually transfer this command to ZSH for ZSH to run the command. This is actually interesting to know because then you can build your shell on an existing shell in the user's device. So what I can do here is to run OS system, and I can just run OS system everything like this. And it's going to run all of that on the default shell that I have on my system. Now the default shell, like I showed you, is ZSH, but in your case it could be bash or it could be something else. But doing something like this is just basically saying the system should run this command however that it can. If I should do something like echo something, obviously my shell does not know about echo, but when I do this, it's just going to hand it over to the system and the system runs echo something. If I should run NSL, it hands it over to the system and it runs that. But if I was just doing this, then what's the point of my shell if my shell is not doing anything interesting? Well, in that case, I can do some interesting things with my own shell. So for example, here I have some commands that I have created for my own shell. There is echo, list directory, make directory, change directory, get system info, help command, and I expose all those commands here. So when you have make dar, it calls the make that directory function, cd change directory function. So now instead of just calling OS system and the command that the user enter, I can do this. So here I've imported the commands and I can say if the command is in commands, then try to run that command with the arguments. If that fails, we throw this exception. I can also color this red. Actually, let me try coloring it red. What is the terminal string combination for red color? Okay, so this is for red. So here where I have color, I'll call this yellow. Okay, so this apparently is red color. So I can come here and I can pass red color and I can pass this function. So now that I have this, I can now run the commands I have here. And if that command does not exist, then I just default again back to the system. So I can run echo something. It's going to use my own echo. Now let me try throwing an error. Yeah, I'm going to call change directory, which is my own shell's way of changing directory, which since I'm using Python calls the change dar function, which would interact with the operating system to change the current working directory, change dar, and I'm going to say directory that does not exist. Now when I do that, it says directory not found, directory not exists. And why is it not red? It's not red because I'm not throwing the exception. I am actually here in change directory. I am actually handling the exception here. But let's say I wasn't handling the exception and the parent has to handle the exception. If I run this again and then I try to do cd directory does not exist, yeah, now it's red because I'm not handling the error here. So when it gets here, then it actually prints the red color. So you can add your colors, you can play with stuff, and you can do things in your own shell that you would like to see. This is very useful because creating your own custom shell allows you to have that, whatever commands you find yourself repeating a lot or whatever ways you want your shell to work, you can actually make it work. And if you can also make it faster, then kudos to you. And another thing is you can make your shells do stuff that other shells do not do. Like there's one thing I like about ZSH. If I open a new tab here for ZSH, if I want to change directory, I don't need to do cd and the directory. Let's say I want to go to the parent directory. Now, normally you would do cd in bash and you go to the parent directory. But with ZSH, I can just do this and it will go to the parent directory. Look, it goes to GitHub, and if I go back into the shell directory, it goes into the shell directory. Now let's assume ZSH was not doing this, but you want your own shell to do that. That's very easy. We have the command from the user, right? And then here we have the arguments. We can say if the length of the arguments is 0, that means the user only entered a command. Maybe that command was ls, maybe it was something, it was whatever. It means they just entered one word. Now we can have an assumption here where we say, assume that the command might be a directory. So instead of first checking if the command exists in our commands here or running that on the system, we can just assume it's a directory. And if it's a directory, we just change into that directory. By assuming it is a directory, we can now check, does directory exist? Actually, I think the best name here is directory exist. And here I have a utility function which checks if a directory exists. I can use that here in my main.py, check if directory exists, and I can pass the command. We're assuming the command might be a directory. If directory exists, then we can change directory. We can call os change dar and we can pass the command as a directory, and afterwards we can continue the while loop. But if that directory does not exist, then we just continue with what we usually do. Now by doing something like this, I've introduced a functionality where I don't have to do cd something. Now if I do this, it's going to assume that is a directory and it changes to the directory, and as you can see here we have GitHub, and I can go back into shell and we do this. But now when I try to do echo, it checks if that directory exists. That directory does not exist, so now it comes to this line where it checks my command list, and because I have echo here, it is going to run the echo function. But instead of using echo, let's use this command sysinfo. Now when I run this, it shows me my system information by running this command that I have here for get system information. But then when I enter something like cat, I don't have cat in my shell, so when I do cat.main.py, it's going to transfer, or it's going to hand over this to the system to run cat.main.py, and now we have cat.main.py running here, and I should have introduced a new line, but I did not introduce a new line, so we have that. Now there is a lot more you can do with this, make your shell as interesting and whatever, but one last thing I want to show you is how when you start your terminal session, it should use your shell. Because now if I should start a new terminal session, I create a new tab, it uses ZSH, and in your case it might be using a different shell, but I want it to use my own shell. I don't want to always have to be typing python main.py before it uses my shell. That's the next part I'm going to show you, but my camera is currently hot, so I'm going to let it cool down a bit and we can look at that. All right, I have my basic shell, but I don't want to always have to be writing Python 3 main.py just to open my shell. I just want it to open when I start my terminal. This is why I can set my Python shell to be my default shell. If you open etc/shells, you're going to see the acceptable shells that you currently have on your device. But I want to add my shell here also. So I'm going to open this file and I'm going to add my shell here, which I'm just going to copy this. Obviously, I could move this to the bin directory, but I don't just want to do that. So I'm going to put my shell here, main.py. I don't have the permissions and I have to do this as sudo. What's my password again? But obviously for this to run, it needs to be an executable file, something you can run by itself. And then at the top here, I'm going to put a shebang where I tell the operating system to use this interpreter to execute this file. And then I'm also going to add the executable permission for this file, main.py. But just doing this doesn't make it the default yet. It just makes it one of the shells that my system now knows about. And now to change this to my default shell, I'm going to do chshs main.py, enter my password, and this is now my default shell. So whenever I open my terminal or I open a new tab here on item, it's going to be my new shell. Now, if you're wondering why we had to add this here, we had to add this to the shells here, because if I try to add a shell that is not here by using change shell command, it's not going to work. So I have to put it here to inform the system this is an acceptable shell that you can use. So now if I open a new tab, see, it opens my shell here. Or if I open my terminal, you can see again, the terminal now opens with my default shell. And now I can go into documents. I can either do cd document, or I can just do document because I added that functionality. It goes in there and go to GitHub, and I can go into shell. And when I do ls, I can see all of the files in this shell. There we have it. If I still want to run ZSH, I can do ZSH like this, and it will open the ZSH shell. If I want to do bash, I can go into the bash shell. Here is something I need to be aware of. Now, if I should do Control C on this shell, because in the script here, Control C breaks the loop. If I do Control C, keyboard interrupt, it leaves that shell and closes the terminal window. Now, I do not want that. I'm going to open the shell again. Or actually here, I'm just going to do something like you cannot leave, sorry. So let's just keep it like this, and then I can remove the break. So I'm going to open a new tab and close the previous tab. So now if you try to do Control C, it says you cannot leave, sorry. Now this might not be the best user experience. You want to give them options if they want to close the terminal or leave the shell. But for now, I have stopped the user from leaving by using Control C. So this is a basic idea of a shell. It takes input, processes the input, and you get output. You also want to look into security best practices if this is something you want to expose externally for others to use. You also want to make sure these commands are fast, or there are optimizations in place. You want to check all of that out. So this is the basic idea of a shell, but there are a lot more things that can go into creating shells. You can make them even more interactive, handling arrow buttons. So if the user presses up, you know where to go up, or you go down, you go right. Because for example, look, when I try to go left here, instead of actually going to the, like moving the cursor left of the character, the terminal sends this input to the shell, but then the shell doesn't know what to do with this. If I do the right arrow, we also have this. If I do Control L, which in ZSH will allow me to clear the screen, the shell doesn't know what to do with this input. So the terminal sends this input to the shell, but obviously the shell is not processing this input. And so we have this. So it gets more complex when you want to do a lot more things like this. You want to pipe, you want to redirect output from a command to a file or error. It gets more complicated. I think in this case, the solution would be that instead of reading the whole input, I read character by character, and then when the user should type something like this, well, they won't type it like this, but when they do left or right, I can move the cursor from one position to another. Those are things I can do in the shell, and maybe I'll make a part 2 of this video where I do those things. The code for this, by the way, will be available below, so you can check it out. Yeah, this is where it gets very complicated, but this is the basic idea of a shell. You can create your own custom shell, do interesting things with your shell, and I'm very curious what you're going to build after watching this video, so do share in the comment section when you do. This has been an interesting video and interesting learning for me. I hope it was for you too, so please give it a like if it was, and share this video and subscribe for more videos like this.